So in the second example here, I've decided to take a look at a little bit more complicated graph that actually ends up looking like a graphic. I labeled this g of x, and we're going to do some transformations on g of x. And so what you do is you first just define the pieces of the graphic by taking a look at different elements of the picture by using points. So for the picture of the circle on the outside of the smiley face, I just used these 4 points and I labeled them here. And then for the eyes, they're already points, so I just wrote down those points. And for the smile, I used these 3 points. You could use more, but I figured this shape was easily described using the elements that you see here. So in the first example, we're going to take g of x, which is a smiley face, and we're going to multiply the outputs by 2 by having this a. And then we're going to have an h. Remember, the easiest way to look at this is opposite of what you see, so it's going to add 2 to the input values. So what should occur is we should get this graph, which has been stretched vertically only, but not horizontally. That'll be a really good picture for you to understand what vertical means as opposed to horizontal. And then the graph will move forward 2. All right, so we're going to multiply all the output values by 2, add 2 to the inputs. I'll do the inputs first. It makes sense. So that just means we're going to go to each one of these inputs and add 2. Kind of tedious, but it really helps you go back and look through your work if you do what I've shown in these examples by actually doing this. It's just really easy for the brain to play tricks on you. You accidentally add something wrong, even though it's really easy, and you don't know why. But if you do this, you'll catch your little mistakes pretty readily. All right, so I'm going to add 2 here. Negative 2 plus 2 is 0. 0 plus 2 is 2. 2 plus 2 is 4. 0 plus 2 is 2. Okay, here we have negative 1 plus 2, which is 1. 1 plus 2, which is 3. Negative 1 plus 2, which is 1. 0 plus 2, which is 2. And 1 plus 2, which is 3. All right, so now we'll do the multiplying the output values by 2. So each of these gets multiplied by 2. One of the most common errors are the easiest ones. So don't forget when you're multiplying by 2, that 2 times 0 is in fact 0. That's the most common error that people make, is they accidentally say it's 2. So just be careful. 2 times 0 is 0. 2 times 2 is 4. 0 times 2 is 0. And negative 2 times 2 is negative 4. Notice what happened there. The output values in the vertical direction were increased, but the horizontal directions, they stayed the same. 1 times 2 is 2. 1 times 2 is 2. 0 times 2 is 0. Negative 1 times 2 is negative 2. And 0 times 2 is 2. All right, so we'll give this a graph, and we'll take a look at what happened to it. 0, 0 is here. 2, 4 is there. 4, 0 is there. And 2, negative 4 is there. So you can see that the horizontal axis is still the same length of 4, but now the vertical axis is now doubled. The eyes are at 1, 2, and 3, 2, and the smiley face is at 1, 0, stretched to 2, negative 2, and at 3. See, maybe that mistake I said people make, 0 times 2 is 0. Self-fulfilling prophecy there. So that point should have been 0. It's kind of funny that I said it, and then there it is. So just believe me when I say that some people, especially when you're just doing monotonous work like that, they make little boo-boos because of the fact that their mind kind of wanders. Okay, so there you can see the smiley face, and it has been stretched vertically. But if you keep a record of what you do, you can easily go back and see your mistakes. So it's the same picture, stretched vertically and moved 2 to the right. All right, let's take a look at another example where we're going to multiply the output values by negative 1, causing a reflection over the x-axis. And then this, notice that this is outside of the parentheses. So that is definitely a K and not an H because the parentheses indicates that it's outside. All right, let's take a look. So we're going to subtract, we're going to multiply the outputs by negative 1 and subtract 2 from them. So nothing happens with the inputs at all. So we're going to be multiplying by negative 1. Again, just keeping track of what we did. And then after we do that, we're going to subtract 2 from that answer, from each one of them. All right, so 0 times -1 is 0, minus 2 is -2. And then -2 times -1 minus 2 is -4. This will be -2. This will be 0, because negative times negative is positive 2, minus 2 is 0. -1 times 1 is -1, minus 2 is -3. Again, -3. Here we'll have 0 minus 2, which is -2. Positive 1 minus 2 is -1. And then 0 minus 2 again is -2. And the input value is unchanged because there was no B or H. There's nothing in that parentheses, so we're just going to copy them down again. Okay. All right, now it's just a matter of graphing. All right, let's take a look at what this looks like. So what it should look like is it should reflect and then move down 2 units. So -2, -2, 0, -4, 2, -2, 0, 0. Notice there's no stretch or compression on that circle. -1, -3, 1, -3, -1, -2, 0, -1, and 1, -2. So to draw the picture, the circle's here, so that's pretty easy to see. Okay, so here are the eyes, and here is the smiley face. So as you can see, it reflected over the x-axis. So that happens first. Basically, the eyes go down and the mouth goes up. And then it shifted, and the circle obviously will do the same thing, but you can't see it because it's symmetric. And then it will shift it down too. All right, so for our last thing we'll do is we'll do an inverse. Remember, inverse simply means take all the inputs and change them with the outputs, change the domain with the range, and vice versa. So very easy to do. A lot of kids get stumped on this. In my opinion, it is the easiest thing to do. But you're going to want to make sure that you're actually switching all the points, because sometimes in math when things are easy, it's actually very easy to overlook. So, if you need to, maybe draw the arrows. You don't have to, but maybe that helps you not make a mistake, because, 1 point, and it obviously will be all backwards. So that helps do it. All right. All right, so now we're just going to graph that. And what it should do is, remember, an inverse reflects over the line y equals x. So 0, -2, 2, 0, 0, 2, -2, 0. That is symmetric, so it reflects over the line y equals x. It doesn't look any different. Okay, 1, -1, 1, 1, 0, -1. Oops. So 0, -1, -1, 0, and 0, 1. So I obviously graphed 1 point wrong. It's this point right here. I'll fix it. So I'll go back to the eyes and just do that again real quick. And it's important to see these little things that your brains can play tricks with you on. So 1, -1, there's so many of the same number here. So 1, 1, 1, -1 that I accidentally graphed that wrong. And that'll happen to you as you do it too. It's just normal everyday things that happen. So as you can see, the circle itself it didn't stay the same. It's being symmetric. It looks like it's the same, but it did reflect over the line y equals x. But you can clearly see here that the smile and the eyes are what you can see in that reflection. So the original eye that was here and here, they're now over here, and the smile is over there. All right, I hope that was very instructive and helpful for how transformations work, especially with points and seeing the compressions and the movements and the reflections and the inverses happening point by point.